Okay, so
hello. So we're going to start this presentation for the course that is called Avoiding the Cosplay in the Software Design, which is going to be given by Pablo Bermejo. For me, it's very happy that Pablo is giving another talk because he's a frequent speaker here in the School of Computer Science, and also because he's a past student, so he started here as Luz. And he, in this case, is a lead software architect in the company DXC, which is an international company which is here in, it is in all around the world, but there is a place here where in Avilés, in Asturias, so he's working from here, from Asturias. And I take this opportunity also to present, because the other day we were going to present this book. This book was written by Pablo, and it's called Building Software Platforms. And also, I am very proud that a student of here at the school not only is a lead software architect, but he's also writing books, especially books about software architecture, which is exactly what the course. And the book is a quite interesting book, especially about software architecture. So if you want to buy a book, this is a good thing. And apart of what he's going to talk, my advice is that you take this opportunity to ask Pablo any question that you want about not only what he's going to talk about today, about these things about building software platforms, AWS, and so on, but also about the profession, about software architecture, how is software architecture here in Asturias, these kind of things. Because he has a lot of experience. I don't know if it's more than 20 years or what. Yeah. He has a lot of experience working in the field in software architecture. So probably if you have any interest in this, you can ask him. So take this opportunity to not only to attend, but also to ask him any question. Okay? This was okay.
Okay, no, let's not work now. Speak about that. See, that's it. No. I did need to find the focus, but the other screen where it is. In this? Yes, here.
Okay, so without further ado,
thank you. Thank you for the introduction. I'm not sure if you guys and folks, you know DXC technology. If you've ever heard about it, it's a company, it's a multinational company that's here in Spain, in Avilés. It's a center. If you go to the beach, if you go to Luanda, for example, there's a big runabout and it's a big building in Avilés. So that is DXC technology. That's what I work for. As Laura said, distinguished architect. Distinguished means kind of recognition. It's like, that senior type of profile that we see in Spain. You can, today I'm going to talk about, as Laura said, serverless and software architecture. I know it's early in the morning today. I don't want to give you like a very heavy talk about all these kind of things. So interactive. So if you have questions, if you've got doubts, raise your hand and ask me things, because let's make this as much as conversation as possible. Many of the things that I talk about here today, I also write about it in Twitter. So I'm an avid Twitter user, and you can find me there. Basically, every time that, if you follow me on Twitter, that's basically what you're going to find. I'm talking about serverless, so I'm the brother-in-law, as you know, in Spain, the cuñado of serverless, that's me. So if you go to Twitter and you follow me, you will hear a lot of stories about serverless, and Pablo is the cuñado of serverless. And also, I wrote a book about it. As Laura said, the book is not only about serverless and AWS and platforms and all these many things, but there's a lot of architecture principles. And the principles are very important in software architecture because the principles guide you and help you make decisions. So basically, I have this picture in my mind, basically is, one of the responsibilities of a software architect is technology strategy. Is to decide the strategy of the technology in a company or in a project or in a product. So in order to make, steers and decisions about where you're going, you need principles. So those principles are the icons that help you steer in one direction or the other. So, and that's the role of that. Okay? Or at least that's the role of software architecture, but I'll speak to that in a minute. So, again, if you find the book on the store that is available for you, that means the actual footage of me at work. Every time I can use it, this is my book, and this is because I'm saving my book. So this is actual footage of me at work. Okay, so let's go to the point because I can start talking about all these things and we'll never get to the point. So the first thing, I divide the talk in two. You will find that slides are in Spanish, some of them are in English, it's a mix. But I think everybody here speaks either English and or Spanish, so that shouldn't be a problem. Anyway, the first part is strategy and technology direction. Again, it's a very, very important attribution of a software architect or in software architecture. It's to decide and to make technology choices and decide the technology strategy in a company, in a product, or in a project. Okay? And here we can even talk about, because many times I have these discussions at work, what is a software architect or what is software architecture? I'll explain that in a minute. But basically, the role of a software architect is very easy. It's somebody that 100% of their time they do software architecture. The important thing is software architecture, which is design and high-level. Again, we're not going to talk about that later. But many companies, you will find out there, not every company has the role of a software architect. Okay, and that is because the software architecture can be elaborated, can be done by multiple roles, even by engineers. I mean, so that is something that I had a lot of conversation at work, and we can talk about that too. Okay, so technology strategy. What do we use? I mean, technology strategy, technology direction. So direction means something. Okay, direction is where do we want to go? Okay, so when you are heading towards something and you are wondering where do you want to go, what do you use? You use a map. Okay. So a map in software architecture is something I'm going to use right now. There is a technique that is not very well known, but it's a technique that I use a lot, and everybody, in the world of software architecture are starting to use more and more. Is one thing, it's called the Worley maps. Worley maps is a technique which has been invented by a guy whose name is Simon Worley. And basically what it does is providing you a framework, a decision framework, or a decision model. So you can basically use a technique that when you use it, it helps you identify where you are and make technology choices. Okay? Let me put you an example so you understand how to use a working map in software architecture to make technology choices. So those three things I'm going to talk about then the next 30 minutes. Again, working maps to make technology choices in software architecture. So this is a typical, I made it up, it's very quick and dirty, as you can see, it's a diagram, okay? It's a typical diagram of a standard application, right? So you've got, basically you've got at the top, the content distribution network, which is, basically it's a cache where the content is distributed, and of course we've got the user interface, some application, in React, for example, an API gateway where the REST APIs are exposed, the backend application with all the business logic, the database where the storage is stored, the server that runs both the application and the database. Even at runtime, you might be that you're building a backend in, I don't know, in JVM or Node.js, so that's it. Okay, so this is a diagram, and this is an architectural diagram. Okay, this is the same thing, but instead of boxes, I painted with circles. But it's the same thing. It's a diagram. So my question is that a map? Does it help you? I mean, if I present this to you, you will be able to decide technology choices and direction. Of course, the answer is no, because that's not a map. So this is the same thing as this, right? Imagine this. So do the same, making a comparison between technology now we're putting the cities. This is Madrid, Oviedo, and Santander. And we know that between Madrid and Oviedo, we know there is the A6. And between Oviedo and Santander is the A8. Do you consider this a map? There are obvious things that doesn't make a map, okay? No, it's not a map. Basically, we need to know what is the north. We need position. Because here, basically, if I present you this without kind of anchor, or kind of, you know, where the north is, you don't know if Madrid is at the bottom of the north and the south. There's a lack of context here, because you don't know where the position of the cities are, right? So it's not a map. We need to know the north, we need to know the position. In software architecture, actually in software, in IT, in every project, you know, whenever we build software, we build, you know, products. What is the north? What is the anchor? What is the direction to go? It's the customer, it's the final user. That's the north. That's the anchor, that's the main goal we always have to have. Software architect, when we build products, when we build software, is we are doing something for a final user. That's the north, okay? So if we add position to the diagram, remember the diagram I presented you before, okay? Now let's introduce the vertical axis, and we call that the position. And the position is where the different elements are rendered, are plotted in this kind of diagram now, compared to the final user, to the north. Basically, what is more visible to the final user and what is less visible to the final user. So now, look at this. To the user, the most important part is the user interface, because that's what they use. Okay, so that's the most visible part. Then, after that, the most relevant and visible things are the backend application, which is the logic they execute, the user interface, the API gateway at the same time, because more or less through the browser, they are actually interacting with the API, with the API gateway. The content distribution network is absolutely invisible. It's not very visible to them. They use it, and the content is served to them through the content distribution network, but they don't see it, right? And of course, the database is visible to them. It's absolutely invisible. But it's important, okay? The runtime, Node.js. Do they see Node.js? No, they don't. But again, it's very important because everything runs on Node.js or JVM, right? And finally, the server, devo aspettare, and finally, the servers. So, do they see the servers? No, they don't see the servers, right? So, but very important. So, now the question, is that a map? No, it's not a map because, right, okay, we are still missing something. It's the same question. Is this a map? That is the position. Right? Okay, we know more or less that Madrid is there, Oviedo is there, Oviedo is to the north, and Santander is to the north at the same height, right? And Madrid is to the south. We've got position. But is that a map? I mean, there is something else. With position only, we can't determine what is the direction we should go, right? It's not a map. We need to have direction. And this is where, in technology, we are starting to use maps. So I have added to our original diagram, I have added horizontal axis, which is the movement, represents not only, now remember, the vertical position, the vertical axis represents the position, and the horizontal axis represents the movement. So the original diagram, okay, with this, now we are starting to have a map. Okay, so let me talk about the movement because that is very important. So the movement, what is movement in technology? I mean, technology moves. How is that possible? Why technology moves? The movement is about evolution. It's about how the technology starts being something that nobody uses to the point where everybody uses it. Okay, so that is what I represented here in 4 stages. Genesis is when something is springing, something is very new, and it's a pure innovation. For example, quantum computing. I'm sure that you heard about quantum computing. Quantum computing, there is a lot of research. IBM has a quantum computer, but it's as big as this room. Do you consume quantum computing in your daily adventures, you don't, because it's not industrialized. It's still in their genesis. You need to go to one place, to one concrete provider that is building something with all the research and money in the world. It's very, very expensive, and there's only one, which is the quantum computer. So that's the genesis. Maybe in 50 years, when I come here and Laura and myself, we are here talking to the next generations, we will talk about how we use quantum computing at home. But today it's not industrialized. It's not accessible to consumers, right? Then the next phase is custom build. So it's past genesis. There are things that here that are being elaborated. For example, crypto. More or less, crypto is something that everybody is trying to build their own, their cryptocurrencies. So all the crypto bros in the world are building their own crypto, right? So it's something that is custom built, right? Everybody builds their own stuff, right? So there are many examples in custom build. For example, when you build an application, and you for a customer says, hey, I want you to build this application for me. That application that you build for them is custom built, right? So you use technologies and you use techniques to custom build that, right? Then the next evolution is when instead of that, instead of custom building things because they don't exist in the market, you buy them for the market. But you buy them as a product. For example, I'm sure that nobody here in this room would build their own JavaScript server, like Node.js, right? Imagine that you are building or an interpreter, or another TypeScript interpreter, another JavaScript interpreter, or another JavaScript content. Why? Because there's already a few in the market. Dino, Node.js. Would you write even your own JVM? No. I mean, there are multiple JVMs. Oracle, OpenAPK, and some other JVMs. But also this applies to products as well. Kubernetes. I mean, would you write your own orchestrator and container orchestrator? No. You would, buy them, right, from the market. And that is because people are not building their own container orchestrators and JavaScript runtimes and things like that, right? And the last thing in the evolution is when this, instead of a product that you buy, and then after buying, it's important. When you buy, when I say buy, it's free, but I mean download, for example, right? You own it. Imagine you are installing a new product project and you need to run the JVM or Node.js or Kubernetes. You need to download them. You put it physically in your machine or in a server, but you own it. You configure it, but it's a tangible thing that you've got in your computer. So the next phase in the evolution of all this is basically when instead of buying things, you subscribe to things. It's a commodity. It's not even something that you buy. It's something that is out there, and you pay some money with your credit card, and you pay per use. Okay? So that's the next thing. Can you imagine, for example, that you need Node.js or JVM, and instead of downloading the JVM or Node.js, you subscribe to it? That is how it works. That is where I am already introducing the concept of serverless. That's exactly what's happening with serverless. That rather, instead of owning your own runtime, you subscribe to a runtime and you pay only for use. Imagine you have a program, and the program takes, 5 seconds or even 200 milliseconds. Okay, you only pay either by 200 milliseconds or 5 seconds, because that is what the industrialization and the infrastructure of the runtime commodity means, right? So we started from something that you need to make a travel, you need to go to the United States and visit IBM to watch and see and touch and use the quantum computer, to something that you pay by milliseconds on a credit card over the internet. Okay, so look at the evolution. Maybe, again, in 50 years, you can subscribe also to a quantum computer, but today it's in the genesis. Okay? So that is the movement. Imagine that I'm coming from an explanation about maps and positions and things like that, right? So that is the movement I want to talk about. And technology, this is very important, because this is going to give you, as software architects in the future, as software engineers, it's going to give you a decision model, a decision framework. So you can say, oh, why? So here, maybe instead of building our own thing, maybe we need to look at the market, and maybe we need to consume something as a product, or maybe buy it as a commodity. And those are the technology decisions that software architects make. Like, I need to understand the context and decide what do we build and what do we buy. So basically, in our diagram, this is a map. Okay? Look at this. I started from a diagram that has no north. I mean, I just down there, an architectural diagram, and I introduce position towards the customer, right? What is more visible, more important to the customer, and what is less important to the customer. And now I have to introduce also movement, meaning what is the thing that you can build yourself. For example, the user interface. I mean, if a customer asks you for an application, would you buy the user interface from the market? No, because you need to custom build it for them. You need to understand their requirements, and you need to build something for them. I mean, it's very, quote unquote, difficult to find something out there in the market that fits 100% their requirements. That's why you need to build the user interface for them, or you need to build the backend. Okay, but if you, for other things that you don't want to build, for example, would you build your own API gateway? No, you buy it. Would you build your own database? Of course not. All those things you buy them, right? So then look at this. There are many things in the product stage. These are the things that you no longer build, now you buy them, right? And the content distribution network, I intentionally put there, is something that is not even something that you download, like Node.js, ABM, a database, a server, right? It's something that you subscribe to. It's kind of in the commodity space, right? What does it mean? This means, and this is very important, up left, this is the important stuff. This is the stuff that matters to the final user, which is the interface they're going to see and the business logic. That is exactly where a software architect, or at least developer, should put as much focus as possible, because that's the part that's going to solve a business problem for the final user. The rest is undifferentiated work, and this is very important, right? Because it means, I mean, a customer, do they care about you use a JVM, Node.js, NoSQL, Postgres, NoSQL, a server, what database do you use, if you use an API gateway or not? They don't care. They don't care about it. I mean, of course, you care because the decisions there affect how you build an application, how you release them, how quick you can ship them to the market. But technically, they don't care, as long as you are building software that solves problems for them, right? It means that when you are in a company and you are competing with each other, this is very important, because when we work in companies, we compete between each other. So imagine DXC, which has a lot of competition, right? And you know, we are building products every day. So do you think that a customer would buy a DXC product instead of our competition because we build our software in Postgres, or because we use NoSQL? I mean, no. There's nothing magical in that. They buy it because we solve their problem. We've got a better user interface, the business logic is the fastest, and the business logic is very optimized, and they really like how our software works. And that is the important part of it. Of course, this affects, but what I mean is, there is no difference between two companies. There's no difference here. This is the cost of doing business. This is the cost you need to pay to build an application, right? So imagine, as a software architect, this is an important decision, but in terms of holistically where you put your efforts is in the outlet. So we have moved from architectural diagram, where I plotted all the elements there, the application, UI, server, database, blah, blah. We have moved from there, at the beginning, my third slide, to an asset, to an artifact of technology strategy. Just by adding position to the user and movement, which is basically compared to the evolution, right? And this is very important. Okay. I mean, you've got questions or you want to interrupt me, and you go ahead. If not, I can speak for hours already. Okay, so what is the movement in this diagram here? Okay, so I just render these elements there. Do the elements move? I mean, a runtime is a product. Again, I put it here as a product because I think of it as Node.js. I download Node.js or Dino or a JVM from the web page. Just click download and exploit it in my server, or in my laptop, okay? So how servers move. Servers up here, you can think either a physical server or a virtual machine, okay? So it's there already in protocol. How do they move? How do they move to the next stage? What does it mean? So where is the movement? Now this is a map. Okay, now here is literally a map because we have position and movement. We know that Oviedo and Santander are exactly at the same, let me say, height. Okay, it's to the north, and the distance between Oviedo and Santander is shorter than between Oviedo and Madrid, and Madrid is to the south. Now it's a map because we've got position and movement. Okay, so this is the same as this. Again, the movement, folks, is here. So how things evolve, how things move from runtime as a product to runtime as a service, server as a product to server as a service, or a database as a product to a database as a server, or even an API gateway as a product or an API gateway as a service. As a service, you start to see where I'm going, right? I mean, this is as a product, this is the as a product economy, and this is the as a service economy. So every time you hear about database as a service, functions as a service, platform as a service, software as a service, everything as a service, is because you are accessing something in this level of maturity, in this level of evolution. It's because you are accessing something as a commodity. You are subscribing to it, you don't own it, you give your credit card and you pay only for consumption. What is that in a world of infrastructure, in a world of databases, API gateways, content, databases, runtimes, servers? What is that service? That's servers. Serverless is basically that. Basically is runtimes as a service. So you don't own the virtual machine, you don't own the hardware, you don't own anything. Traditionally, I'm sure that you guys hear about infrastructure service, software as a service, where you go to AWS and things like that, and you spin up a virtual machine. So you don't own physically, you don't own the server, right? In platform as a service, you don't even own the virtual machines. They give you like a space where you can drop your code, and you've got something running. But the next evolution is runtime as a service. You don't even own Node.js or the JVM. That's given to you. That's given to you instead of a product as a service you can consume, and that is serverless. And that is basically, the title of this talk is about cosplaying. We're thinking, okay, well, Pablo, what does it mean, the cosplay? It means that basically what we need to avoid is development teams, software architectures who are building products to cosplay as a cloud provider. Why is that? Because today, the responsibility, today in 2022, the responsibility of managing infrastructure, managing hardware, managing runtimes is the responsibility of cloud providers. I mean, if you are building software, if you are building something for your final users, the important part, remember, is on the left, is building a user interface and writing the business model. This is a differentiated work. Do you want to spend your time here? No, you don't want to spend your time here. You want to spend your time there, creating value for the final user. So as much as possible, try to consume things as a commodity for a cloud provider. And that's why the title again says, try to avoid the cosplay. Don't cosplay unless you guys hear me. I mean, I'm sure that many of you will end up in a cloud provider. I mean, many of you will work for AWS or Google Platform or Azure. In that case, forget this message because you are for cloud providers and then you are managing the infrastructure for your final use. But if not, if you end up in DXC technology, if you end up in empathy, if you end up in many of these companies, don't cosplay as a cloud provider. Try to focus on writing business logic and try to lean on these capabilities as much as possible. Again, this is basically what I tell my teams. What I tell my teams is, if you are not a cloud provider, you are a company who is building software, okay, don't try to cosplay, don't try to waste your time managing infrastructure that you don't need when the cloud provider does that for you, okay? Questions so far? Okay, so that is serverless. Again, serverless is runtime as a service. Is instead of downloading Node.js and managing, now I can subscribe to a Node.js server running elsewhere, and I pay only for what I consume. What is the impact? Okay, and this is very important. Serverless doesn't mean architecture-less. You still need to design. You know, there's a role of a software architect at the end of the day is to design. Okay, so this is where I started to introduce the differences between design and architecture. So I'm going to read, not sure if you folks, you know this guy, Lama, and I, we know this person very much, because even when we studied, this person, well, I mean, he invented the UML. Well, he invented the book, this is Grady Bush. He invented the book notation model, and after that, together with others, they created UML. And do they still use UML today in school, or? Yeah. Right, okay, so he's the father of UML, okay? And he's a great software. He still works for IBM. So, in his code, this quote that reflects very well exactly what is software architecture. I'm going to read it because I don't know what I mean. So, architecture is making significant design decisions. Okay, architecture is design. But where significance is measured by the cost of change. So, basically, you are doing design. And if you are making a design decision that is very costly to change, that is architecture. It means my design decision, remember the map? My design decision now is to go with AWS instead of Google Cloud. You know, that's like going to Madrid or going to Barcelona. I mean, it's not only a design decision that's going to affect the consequent decisions down the road. That is kind of a software architect decision, or that is software architecture. So, you know, as you move towards that type of decisions, there are decisions that are very, very hard to change. Imagine selecting a type of database from the other. I mean, selecting a NoSQL database versus a relational database, that's architecture in somehow, right? Because at the end of the day, it affects how even you write your code. It's not the same for if you're using NoSQL that you use a relational database. So, but as you move on, there are other decisions that where the cost of change is less and less. For example, again, selecting a programming language is architecture. Because, well, imagine that you start writing in Go, and after 2 months you realize that writing this piece of code in Go is unperformant. You don't find people in the market with Go knowledge, and many other reasons. Or even today, you select Rust. Rust because you know this is popular a lot, and you decide to go to Rust because it's very, very performant. But you've got other problems like nobody understands Rust, or nobody has the skills in the market. Or maybe it doesn't have, it's very good for concurrent programming, but not for writing a Lambda, you know, crunching numbers, I don't know. There are many reasons. Then, imagine that in 2 months you wrote, and your team you wrote like 1,000 lines of code, and you decide that the Rust wasn't the right decision. The cost of change is a little bit high, because you need to rewrite all that again in a new programming language. So this kind of, I mean, my message is, you need to identify what is a decision that is difficult to undo, and a decision that is easy to undo, okay? Okay, so, this is the thing. How serverless impacts that, and that's very important. Okay, very, very important. With serverless,
I have a question about there is also cost changing between cloud providers.
I think you may become.
We did it, it's being recorded.
How do you consider the cost between changing between cloud providers? I mean, can you do it like a mixture of providers, like the database with Azure and then other things with other AWS?
I love this question, and I think I'm gonna speak about that later. But I love this question. So nowadays, now in 2022 is easier than before, because in 2022 there is this thing that we call the equivalence principle. It means that basically you find the same everywhere. You find the same type of technology everywhere. So if you go and you select Azure, you will have Azure SQL Server, or basically a SQL database with SQL, and if you switch to AWS, you find RDMS, which is an older database, but the database is serverless. Is SQL. So today is easier than ever. There is this principle of equivalence that all the cloud providers are building the same stuff. Okay, of course, and this is very important. There is no proprietary in a service economy. There is no proprietary technology. Everything is based on the standards. That's precisely how they became commodities. For example, another example. Google Cloud and AWS, they both have the same concept of runtime as a service. In AWS is AWS Lambda, that I'm sure you heard about, and in Google Cloud is Google Cloud Run. So basically it's the same idea, it's the run function. So it's the same idea. They offer you Node.js runtime as a service. So switching code, imagine that you start writing code for a Lambda, and you say, well, maybe now my company is switching back to Google Cloud, or I need to write the same thing in Google Cloud. How easy or difficult is to move my piece of code into the Google's schema? You need to change a little bit of your code, because at the end of the day, there's always some type of structure that is coupled to the platform, but 80% of what you write is reusable, because all of them are based on the standards. There's no proprietary technology. At the end of the day, it's exactly the same. It is true that they add a little bit of, the SDK and a little abstraction that you need to use, and a little bit of structure in the messages, but at the end of the day, you can reuse 80% of your code. And that's because in 2022, especially when you use serverless, everything is based on the standards. There is no proprietary technology. When you use Lambda, this is no AWS version of Node. This is Node.js as a service. And when you use Google's cloud functions, this is not the implementation of Node.js of Google, and you need to adapt to it. No, this is Node.js. The same as in AWS, it's the same, right? There is a little bit of structures and access points that you need to configure, right? But that's 20%. So my answer is that it's easier than ever, especially when you use serverless, because it's based on standards, and you can reuse 80% of the code.
Well, I have one question about that. Do you, in your experience, do you have experience if it is easier to change from serverless to another serverless than if you go from on-premises to serverless?
Yes, it's easier to move from serverless to serverless, exactly. Because that is one of the characteristics of the commodity stage of the as a service economy. We'll put it here, okay? One of the characteristics of the commodities is that they are based on standards. That's how the only way a company like AWS or Google Cloud, they can offer something as a service, the only way they can do it is by if it is a standard, okay? Because if this is proprietary, nobody will use it. Because if this is proprietary, you will be stuck here. But if you want to move here, that's because exactly they are based on standard. So it's easier to change from Google Cloud Functions to Lambda and Lambda to Google Cloud Functions than if you move from a virtual machine in Google to a virtual machine in AWS. Because, for example, a virtual machine in AWS is not only a virtual machine, you need, there's a lot of structure around it, that you just can't export your virtual machine from Google and move it to AWS. That doesn't work. At the end of the day, you need a lot of global configurations and a lot of things that are attached to the cloud. But when you are doing here, when you're moving here, precisely it's because everything's on standard. It's way easier. Okay. So again, cost of change, decision, software architecture, cost of change. How serverless help with software architecture and the cost of change? Imagine, it reduces that a lot. This is a typical, again, traditional software architecture diagram, kind of the same as we did before, right? kind of the same diagram at the beginning. In red is what the software architects or the responsibility of the software architecture, and blue is the responsibility of the developers, right? So the software architecture or the software architects, they're responsible for designing all the network, the firewalls, the replication in databases, the configuring the servers, configuring the firewalls, the web server, all that. And the developers, their responsibility is to write user interface and business model, right? Okay. So look at all the different, places, all the red dots. So all the red dots are responsibilities for a software architect in a company with building a web application, right? In serverless, the responsibilities of a software architect are way less in number, okay? They've got less responsibilities. Here, they don't have to configure servers, that's the cloud provider. They don't need to configure the runtime or install Node.js or configure that and scale that in and out or do provisioning management. That's the cloud provider. So the responsibility here is to configure the gateway, to configure the cache, the content distribution, configure the bucket where the UI runs, configure the tables in DynamoDB, which is AWS NoSQL serverless service, configure Lambda to say I want a runtime of 1 gigabyte of RAM or 128. So these are the kind of configurations that they need to decide, right? But the important thing to me is that do you need an architect for that? Do you need like one person with the title of I am the software architect sitting in the ivory tower for that? You don't. Developers and software engineers can do that. And that's where I distinguish between software architect and software architecture. Remember, serverless doesn't mean architectureless. You still need to make decisions of architecture, right? But with serverless, the cost of change is way less. Imagine that I say, okay, I just chose, DynamoDB and Lambda and Cognito and S3 and configure that in an afternoon. Because by the way, I can configure that either in the console or writing a script, because all this is has a programmatic action. I can configure that personally, you can do it in 2 hours. And developers in my team, they can spin up something like this in less than an hour, okay? So you can write Terraform script or any other type of script that spins this up in 2 hours. Imagine that we made a mistake. This doesn't work well, the Lambda has limitations, because one of the things you will learn in time is that the way you move up in the abstraction layer, this comes with limitations and constraints that you need to be happy. If you are not happy with those abstractions and the limitations that the abstraction gives you, then you need to go one level down. But this has a trade-off, saying, okay, 2 hours, that's very, very quick, right? But again, it comes with limitations. So the thing is, if I'm not happy with the limitations, this doesn't perform well, the Lambda, the Lambda function is too small, something like that, and I need to revert my decision and say, I can't go with NoSQL. I need a relational database. I'm sorry, but we made a mistake. We can't implement this with Lambda. We need to run things in a container with figures, something like that. The cost of change in this environment is very little. I can say, oh, okay, I'm going to, instead of Dynamo, I'm going to use RDMS, or I'm going to use simple database. And instead of Lambda, I just copy, paste my code, and move to a container. And instead of configuring a Lambda function, I'm going to configure an ECS task or a container in AWS. 3 more hours. So the cost of change in serverless, when my message here is, has reduced a lot. Because now, in the past, the cost of change, imagine that we have chosen the wrong database, or the wrong server, or the wrong network configuration. And doing that is very costly. We need even to purchase new material, and maybe, we need a couple of weeks to undo the change. Here, making the change is a couple of hours. So that is how serverless is affecting software architecture. Basically, in the past, there was a very strict distinction between the software architects, that make all these kind of decisions, and then developers. The architects, they sit in the ivory tower and they toss documentation to the developer, they pick them, and and the architects, they go to the next mission, which is designing the architecture. Okay. Now, at least in my job, you need the architect to decisions like, do we go with AWS or Google Cloud, what programming languages? The decisions that still are very difficult to undo. But these kind of decisions, we don't need architects for this. Developers and engineers, in our daily jobs, we make these decisions. And this is how serverless is impacting the role of the architect. Again, the distinction between a software architect and a software architecture. Serverless doesn't mean architectureless. You still need the idea of making technology decisions and what to buy and what to build. Remember the map. Okay? You still need that. Okay? That is software architecture. But today, do you need software architects to do all that? Well, maybe not, depending on your context, right? But this is how things are going. Okay. So, it's a diagram like this. This is serverless. Here, this is a typical serverless diagram in AWS. It's very easy. You can do, as I said, you can run a script that spins this up into hours. So basically, yeah, pretty easy. This is actually a real diagram of an application. Okay, so it's not complex. Okay. For a moment, just hold my beer because this can get very, very complex. This is another serverless diagram of a more complex application. Of course, you can see that and it's okay, right? It can really go complex. And there's no server. This is serverless. There are no virtual machines. This is everything. Either all these things are lambda functions. A lambda function is if you develop the lambda function in the right way, it's no more than 200 lines of code. It's a function, right? So this is the actual diagram of an actual solution that I downloaded from the AWS webpage. So this is a serverless solution that they have for something. And everything there is no virtual machines. There's no servers. It's pure servers. So it's very complex. So I always have this discussion. It's like, okay, so what is that? It's very complex. So, in my opinion, it's not more complex than a traditional diagram. Actually, if you look at this, the databases there are not databases, they are tables. And these are not servers, they are functions. So, but at the end of the day, this is also a deployment diagram. So, this is how I want to introduce the next idea. You look at this, and if you look at it from a traditional point of view, if you look at it like this, traditional, say, infrastructure, say, if you compare that to that, say, well, that's a lot. The other diagram from AWS, that's a lot. If you compare it with the mentality of servers, databases, firewalls, like infrastructure resources, if you look at this diagram from that perspective, from this point of view, from the point of view of infrastructure, that's very complex. But this is not infrastructure. That's what I'm saying. In serverless, these are functions, 200 lines of code. That one, that's not a database, that's a table. Because this is how the serverless is a level of abstraction on top of all that. Okay. So if you think about it, this is, these are functions, or even objects, or classes, tables. What is that? Do you know what is this? Well, I'll spoil the surprise. This is a collaboration diagram for UML. This is, if you still use UML, this is a collaboration diagram. So basically, to me, this is the same as this. This depicts relationships between objects. And in a UML diagram, this is basically this. The thing is, actually, what happens is that in serverless, you are deploying this. This is actually your collaboration diagram of the different objects, but this is also your deployment diagram because you physically are deploying that on AWS. So what happens with serverless, and this is something that it's an idea that I have and try to explain serverless diagrams. With serverless, you are deploying your collaboration diagrams. That's basically what it happens. When people say, oh, this is very complex. Well, but the level of abstraction is very high. These are objects. These are the relationship between objects. This is something very simple, actually. So with serverless, you are deploying your collaboration diagrams. Okay? Okay, so that's I'm going to pass that. Okay? So any questions before I move on? How much time do you have now?
We have maybe half an hour more.
Half an hour, okay.
So what is it? As you want.
So,
They will not complain if you keep this better.
no.
Questions? No questions?
I the end of the presentation. I have a question, but I was waiting till the end.
No, don't go to the end.
So I saw that in your book and also in some of the slides, you always mention AWS. I suppose it's because your expertise is in AWS. But what do you think does AWS offers that other cloud providers does in order to choose AWS?
Right, very good question. So AWS, one of the things that they do very well is that they meet customers where they are. They don't introduce technology just for the sake of technology. So they implement and try to hear about the concept of MVP, right? The minimum viable product. So AWS, when you are accessing data listening service, you can expect that the service is incomplete. You look at this, it's like, oh, but look at this. It doesn't have this, and this. What a piece of shit, right? It's like, why do I choose this? It's incomplete. But when you choose AWS, you know that basically you are in a path with them. They're going to grab you by the hand, and they will work with you, and gradually they are going to introduce more and more features. So basically, what AWS is very, very, very good at is the concept of MVP. They release an MVP to the market, they understand how the users use it, and rather than at the beginning bombarding you with a complex API, with a lot of options, and you go there and I don't know how to use the service, it's very simple. At the beginning, it's very, very simple. Even to the point that you don't like it, because they say, but it doesn't do what I need. The thing is that if you wait, when you start consuming those services, you know that they're going to keep adding more and more features. And those features come from the customers. That's nothing that they invent, in a room like this and think about the future and say, oh my God, what can we do now? Let's have this feature, and there's another feature, okay? AWS, instead of that, they release an MVP, and gradually, every 2 months, you know that the service is going to be cheaper, you know that the service now, the API is going to be richer, it's going to have this functionality, this is your functionality. So that is one of the things that I like the most. And even in the book, when I mention AWS, I don't talk about, look at the DynamoDB, this is the perfect service, or no, I'm talking about the principles and how AWS approaches software, building software, right? It's like, there is an MVP, and then they keep adding features. So probably to me, in my personal opinion, that's why I like the most about AWS. Also, because the services they have are very, very powerful, they're very cheap, and they've got a rich catalog of services. But today, it's way more and more difficult to just between one cloud provider and the other, because the answer I gave to your colleague before is because the principle of equivalence, you will find the same basically in every provider. But, for example, in my experience, Google, the way they do things is that at the beginning they introduce a very complex product with a very complex API, because they've got the smartest people in the world working on that. But at the beginning, the entry barrier to consuming the service is very high. In AWS, is less difficult.
Following on that, so at this moment I see Microsoft Azure, Google, and AWS. Are they the only ones, or do you know someone who tries to put on top of them a more neutral way? Because I think there are some ways.
Yes.
I have experience on that.
Yes. So now we are entering in the in the future of cloud, where all this is going. Because again, we're in 2022. There's a lot of services, and every cloud provider has a serverless offering. But what's the future like in 5 years, 10 years? What are they doing? So we are starting to see how there are other companies that are built on top of AWS or Google Cloud and other providers. There's also Cloudflare, So at the end of the day, what's happening is that it's going to evolve in two ways. We can see that in probably in 5 years, everything's going to be serverless in the cloud environment, right? There's always been the serverless flavor of everything. Today, not everything is serverless. For example, if you use Kafka or if you use machine learning, that's not serverless. You still need to configure clusters and things like that. But in 5 years, we will have the serverless version of Kafka, the serverless version of machine learning. So all the companies are going to have a serverless version. It's inevitable. That's how it's going to evolve. So how are they going to introduce new, the cloud providers introduce new services, not the serverless flavor of something, but new services. We are starting to see that there's a lot of use of something that's called edge computing, which is the CDNs, where instead of the cloud, these are data centers or locations that are closer to the user, and we are starting to see how this AWS is investing a lot in computing at the edge, which is locations very, very close to the user where you can run a piece of JavaScript there. Okay, so they're starting to see how the cloud providers start to introduce edge computing services. That's something that again in 5 years maybe we are here again talking about edge computing because that's the next thing. But also, as you said, there are other companies that are building capabilities on top of AWS or Google Cloud, or they give you an abstraction where you don't know if what they have behind is AWS, Cloudflare, or Google Cloud, or maybe it's a combination of both or the three, depending on the type of service. One company like that is Vercel. I'm not sure if you heard about Vercel. I'm not sure if you heard about Next.js, is the service library framework for React. Vercel is that type of company. Vercel is a cloud company where they offer you the ability to write an application in Next.js, which is a React framework, but also it gives you the ability to create what they call serverless functions and edge functions. They give you an abstraction where it's very easy. All what you need to do is create your repository, name, you need to have a folder in your project. You need a folder that's called API, and everything that you put under there, automatically they are going to create a Lambda function for you, or a Cloud Run function for you, or a Cloudflare worker for you without you don't care about it. All what you need to do is, I need to put my piece of code in this project repository, and Vercel, doing the combination, doing the build time, they're going to create the bundle, they're going to split my code in different pieces, and they're going to deploy it in AWS or any other. All what I did was, I wrote my application, I put my piece of code for the server part in a folder called API, and Vercel took everything. So this is the next thing that are happening. Companies that are building services and functions for developers, improving a lot and investing a lot in developer experience, building on top of AWS. And that's cloud also, because they offer you a cloud computing solution, but at the end, rather than owning the data center, what they use AWS. And I've got a couple of slides for that as well, but if you want to talk about, serverless, I know that for many of you sounds like the future, but serverless is now. Today, if you start a company, and if you join a company like in 2 years, serverless is the way of doing things. There's no other way right now. Companies that are not in the cloud, those companies are dead. Companies that are not in the serverless economy today, they will be dead in 5 years. So in 5 years, the future again, what we're going to talk about is edge computing and companies like Vercel, Netlify, and other these layers of abstraction. This is how things are evolving.
This is more of a personal question, but I would like to know what was your career like from you being a student to becoming a software architect?
Of course, thank you. Yeah, thank you. So, well, it's been bumpy, as you can imagine. So basically, when my first, I'm going to start from the beginning. My first day at university was with logic. Yeah, it was my day one in 1998. That was my first day in university. And Laura was the first teacher coming down here and explaining logic, right? Okay, I started to work 20 years ago, in 2003, actually, 19 years ago. I started as an application developer, okay, and then One of the things that happened in Spain at the beginning was that there were only a few places where I could work. Madrid, 2003. If I didn't go to Madrid, here in Asturias, what options do we have? I mean, we had CSE, Capgemini, and nothing else, right? So I joined CSE because I didn't want to go to Madrid, and I stayed here. So CSE is the exit. They changed them, right? And so I've been with the same company 19 years already. So basically, I think it's a natural evolution. The natural evolution is you start being a developer, gaining experience. At the beginning, this is something that I did, and I recommend all of you, is to grab experience from multiple projects, from multiple ideas. I had the luck, and the company is big, so I can, within my company, I switch it from project to project almost every year. So I could see the world, I could see different options, different technologies, because I wanted to learn. I didn't want a position where, I go there and I do my job for the next 5 years. It's like exactly the same. I didn't want that. And again, you've got two options. Either you change companies or you change projects. So in my case, what I did was changing projects. I have the opportunity to change, and also I lived abroad. One day, they called me and, hey, Pablo, we've got an architect position in Belgium. Do we want to go for Belgium for 1 year? I said yes. After that, I came back, and then I was in Australia as well, because the company is big and has a lot of opportunities inside. If the company wasn't big and I wouldn't have those opportunities, I probably would have switched companies, because that's the way you can progress. Moving the ladder is by switching projects and gaining experience. So in my personal opinion, basically, I think it's what I recommend is curiosity. I checked myself, I wanted to learn more. It's like, okay, I know this already, but I didn't know it. But I want to learn more, I want to see more, I want to see options, I want to form my opinion about things. So I try to move to the ladder. So, yeah, it's a combination of different projects. I also, something that in Spain is very typical is this idea that if you don't become a manager, you are nobody, which to me is absolutely crap. I mean, a manager is you need to, basically you need to manage people, and sentiments, and feelings, and egos, and things like that. And well, I mean, in Spain, this is the consulting mindset that if you are not a manager, you are nobody. Hey, but not in IT or not in a proper company. As a software engineer or a software architect, in companies like today, they're first-class citizens. And that's something that I tried, and now it's changing. In 2003, it was doing that. In 2003, 2005, 6, 7, if you weren't a manager, you were nobody, right? But not today. Today is different. So, my piece of advice as well for you guys is there's absolutely a fantastic career path in software architecture or software engineering. You don't need to become managers if you don't want. If you want because you like to manage people or manage projects, that's fine. But don't do it because it's the way of growing. Today there are multiple opportunities to grow as a developer or as an architect. So how I became? Well, experience, many years, and curiosity. I mean, I could have the option of just sitting at my desk doing the same thing for 19 years, but it didn't work. So basically, it's a curiosity. I wanted to learn and move. Okay. Right. Okay. So not everything is wine and roses in servers. Not everything is fantastic because remember, cost of change. Now I say no. There is no difference distance between architects and developers. Developers and engineers can make structural decisions and design decisions because the cost of change are less with servers. Okay. So, well, this is a sentence I like a lot about Eric Elliott. If you don't know him, Eric Elliott is one of the most popular functional programming experts out there. So, if you are a fan of functional programming, with JavaScript especially, Eric Elliott is your go-to person. He's a superstar. And he's got this sentence I like a lot. It's engineering trade-offs or engineering decisions and stupidity are undistinguishable if you are unaware of the trade-offs. So this is something I use every day. Because at the end of the day, is when you join a company, you join a project, and you see that, and you say, why did you take this decision? are you stupid? I mean, because this is stupid. But you need to understand the decisions behind that. Maybe the person or people who make those decisions have good trade-offs and decided that. And once you understand the trade-offs, you say, oh, that makes sense. Of course, there are always options to make technical decisions, but you need to be aware that when you make a decision, it's a trade-off. Again, when you are in a position to choose between Google and AWS, you need to understand the trade-offs. And after you go to the path, you need to understand all the trade-offs. Trade-off, at the end of the day, is understanding the pros and cons and the implications. Again, not everything is wine and roses in serverless. Now developers have the responsibility of making structural decisions and architectural decisions. I mean, well, yes, okay? So, cloud providers like AWS, as I said, now they are giving us Node.js as a service. They manage the physical machine. They manage the virtual machine, they manage the container, and they manage the Node.js server for you. So you can just drop code and pay only for the use, okay? But complexity like energy doesn't go away, it is just transformed. So it means that that complexity that now is managed by the cloud provider is turned back to you as a boomerang in another form. You know, and that's very important to understand. It's like, oh, fantastic, now you know, the cloud provider manages everything for me. I just need to write code, which is basically the most useful part, right? But the cloud provider managing that for you, that complexity, they take care of that. Again, it comes back to you. How it comes back to you? Okay. Remember, this is the map. Vertical position, I mean the vertical axis, determines position towards the final user, from more visible to less visible to the final user. And the horizontal axis is the evolution of technology. In serverless, we are here, runtime as a service. This is undifferentiated. That's why we want cloud providers to manage that for us, so we can focus on building the important stuff, which are applications, right? Again, what are the implications of that? Okay. The implication of that is that now, as developers, as software engineers, you've got new responsibilities. And those new responsibilities is, as I said, you need to write scripts to create and configure a Lambda function or a cache in a CDN or a NoSQL table, and you developers now are responsible for writing those type of scripts to spin up resources. Now, you developers, you need to understand what is the catalog of options in AWS. Now you need to understand, oh, why, you know, if I make a mistake and I choose NoSQL with Dynamo, and that is not performing well, warrants the other option, what AWS offers me, you need to be aware of that. You know, engineers making those decisions need to be aware of that, okay? So there's new responsibilities, like writing, scripts and being aware, and there's also cognitive load. And when I say cognitive load is basically you need to be aware of more things. You need to understand how the cloud works and all these things, because now is part of the responsibility. Okay? Again, the extra examples I'm going to read them because I don't know what they are. Okay, so the examples of extra cognitive load, how to develop in local servers. Okay, so you say that now AWS gives you Node.js service, but okay, that's in the cloud. How do I develop locally? How do I configure my environment? Because at the beginning, I downloaded Node.js, I run it, I ship the code, and somebody else took care of that. Now, you are developing local packages, you are responsible to pushing that to the cloud. You need to understand how does it work local. Because now maybe you still need to use a AWS SDK, for example. Okay. Select the right cloud service, as I said before, why DynamoDB and not SimpleDB, learn new APIs and SDKs, how to deploy after deployment. It's like, okay, now in the past, when you deploy the server, you log in the service, a virtual machine, you watch the logs, and okay, yeah, I can see my backend application failing here because I can't watch the logs. Now when you move that to the server, to the cloud in the serverless, where are the logs? There are no virtual machines. Where are the logs? You need to understand that, for example, AWS has a service, it's called CloudWatch, that spins out all the, all the logs. but you need to understand how cloud works, right? How to do data deployment, how to access the logs, there are new integrations, all these things, right? So these are new things that software engineers know, but also new responsibilities. As I said, you need to write an infrastructure scripts to spin up all these pieces of resources, set up the CI/CD pipelines, because now we are in DevOps, we know ops, so all those things are things that we can do. But also, this is one of my favorites, and maybe also we talk about this. Now there is a direct implication of your code. As I said, AWS is going to charge you by the millisecond. So if you write a piece of code that takes 200 milliseconds, that's going to cost less than the same piece of code that costs 5 seconds. If you imagine you're writing a backend program, Node.js, and you write it, you ship it, you go there, and then you see the AWS bill. And the AWS bill says that your software is, I don't know, $25, so 25 euros. And you look at that and why is 25 euros? And you see that the Lambda function, every Lambda function takes 10 seconds, or 5 seconds. How is that possible? You debug and say, oh my god, this is, look at the complexity. I was totally wrong. How could I implement this in a for loop? If I put it in a map or something like that, you start to looking at optimization of the source code, because now, instead of 5 seconds, if you reduce it, oh, this is very bad. Now I'm going to change it, I'm going to refactor that. I've got my unit test, I've refactored, the tests are green, and you see that now it's 200 milliseconds. They say, oh my god, this is embarrassing. How could it take 5 seconds? That was my mistake as a programmer, as a developer. Now it takes only 200 milliseconds. And now instead of 25 euros, you pay only 2, because it is by the millisecond. So now, is the responsibility, now the optimization of the code, the cyclomatic complexity, the choices of the quality of your code is more important than ever. Because that has a direct implication of costs. So now you say, oh my god, I'm a developer, I'm running code, and now I need to be aware of how much my code costs. Yes. Trade-off. Everything is everything fantastic in serverless, everything I can write scripts to do it. I don't manage everything, but I can screw my company's bill. If I do it wrong, I can have a program that, is going to ruin my company because the cyclomatic complexity, because I made a mistake as a developer, right? And also, and this is very important, and this is new from like last month, the impact in the environment, sustainability. So how much CO2 my piece of code generates? That's crazy. It's like, okay, my piece of code is generating 2 milligrams of CO2. How do I measure that? You don't have to measure it. AWS and the cloud providers give you tools to understand what is the environmental impact of your code. They say, oh my god, now they need to be aware not only about learning a new language program, and write code in a proper way, and do technical design, and TDD, and write this, but also I need to understand how much my code costs, and the CO2 milligrams that my code put in the environment. Well, this is how things are evolving. I mean, this is the reality. This is the reality. Okay. So, how are companies solving that, or at least one of the DXC we are. How we are solving that? We are solving that with this, building software platforms. And this is how, this is the idea introduced in the book, is basically with internal platforms. Basically, the internal platform, you can think of it as a set of tools for developers, services for developers, APIs for developers, manuals, documentation, guides, configuration, reusable code for developers. So, they don't need to worry about all this. There is a team of engineers, there is a team of developers building tools for other developers. So there's a team, an internal platform, the people working on an internal platform are developers, are engineers. And they do tools for other engineers, so they don't need to worry about all that. Graphically, this is it. Graphically, instead of the people, the developers writing code, instead of accessing all that kind of services on AWS and having all that and understanding, because at the end of the day, this is what we wanted. We wanted people writing code to not care about servers. But now you say, no, don't worry, you don't care about servers. But now you care about cost, environmental impact, and understanding 200 services from the AWS. What is my game? I prefer to care about servers, right? So how companies are solving that? Well, solving that and many others is by creating internal platforms, and again, tools that abstract all that. And there's a platform team is a team that goes there and says, okay, I'm going to tell the developers in my organization, in my company, that today if you go to AWS and you log in the console, there are 200 services. 200. If you want to deploy a container, there are 17 ways of deploying a container. 17. If you want to have a database or no SQL table, there are 12 services. So, what is the game? I mean, yeah, I don't care about services, but I need to understand 200 services. That's why the certification of AWS are so important. I know that, right? But a platform team, what it does is, no worries, developers are fighting. I'm going to take care of that. I'm going to, from the 17 ways of deploying a container, I'm going to choose the best one for my company. And I'm going to write tools and APIs and Terraform code and infrastructure as code script so you can use them, so you can focus on building applications and you don't need to worry about all that, okay? So that is what a platform team does. A platform team, again, one of the main goals is to absorb the responsibilities for the developers so they don't need to care about, where are the logs and how do I consume my service and things like that. But also, reduce the cognitive load. Again, I don't need to understand the 17 ways of AWS. My company has one. From those 17, has picked the architects, has selected one service. And by the way, I've got a wiki page for the markdown. I've got an API, and I've got a script that if I use it, it's going to create that for me already, so I don't even need to worry. So that is what the platform teams do. It's again, software engineers building tools for other software engineers to reduce the cognitive load and absorb some of the responsibilities. Basically, it's this. Okay? A platform team, developers at the end of the day, they can focus on building software, quality software, and AWS, they release new services, and there are other technology providers that release the services, and the platform team is absorbing part of those responsibilities. Answering your question, what is happening? So look at this, look at where do I put an internal platform. An internal platform is custom built. This is not something you can buy from the market. It's something you build because, as I said, it's adapted to the particularities of a company. My company has selected DynamoDB, but if you go to another company, maybe the choice is not DynamoDB, maybe the choice is InfoDB or another. My company has selected Fargate as the way of deploying containers. Maybe if you go to another company, Fargate doesn't fit well, it's Kubernetes or another thing, right? So it is adapted to the context and the needs of the company, of the organization, of the product, of the developers. So you can't buy it per se. It's not something, I'm going to buy a platform. I'm going to configure a platform. We are not talking about buying platforms. We're not talking about configuring platforms. We're talking about building platforms. That's why it's important that the platforms are built. But as I answered Laura before, remember this movement, position and movement. How platforms are evolving. Do we ever have platform as a commodity? Not fully. I mean, not something like resolves 100% of your problems, like absorbing 100% and you say, oh, I'm going to use this product on the market because that's going to solve all my problems. But Vercel is doing kind of that. Vercel is a platform that is absorbing many of the responsibilities for a concrete type of developer, web developers. So web developers, they don't need to worry about, my backend code. Imagine you are now you know that there is a switch back to server-side rendering. Next.js is the next big thing. We are building a lot with Next.js. So we are now back to server-side rendering. Why are we going back to server-side rendering? Well, two reasons. One is because we really need it. The JavaScript ecosystem is a piece of shit today. today, with the thousands of frameworks, you can't build everything in a single-page application. We really need server-side rendering, and also now spinning servers is easier than ever. You know, spinning a server, 2 hours. I can have that. In the past, 5 years ago, 6 years ago, if I needed server-side rendering, I said, oh my God, and I need to talk to these people. They need to buy a virtual machine. They need to spin up. They need to configure. It's going to take 2 weeks, and after that, they need to give me access and the keys and blah blah blah. I put everything on the client, single-page application, and run. Now, no, I don't need any of that. I can do it myself. I can write a Terraform line and have a server running. And I can configure Next.js to run the server side there. Okay? So that's why we are back there. So in a server-side running world, where you've got APIs to consume, you've got all these things, Vercel is helping a lot. And it's not solving 100% of the problems. You still need other things, but if you are building web applications, Vercel is very good. Okay, that was part 1, but I think I'm gonna. I mean, the part 2 is very similar to this one. I mean, I think with all the questions, I think we already can answer many of the things, because I already talked about the product economy and software as a service, what as a service means. Remember, as a service, every time you hear the idea of, oh, this is whatever as a service is. As a service is. It's because you are, it's a technology that is a commodity, and you can subscribe to it. So again, the second part is just 5 slides, and we already gave them, we already covered them by any questions.
Yes. Okay, more questions? You want to?
My question is about how do you make sure, for the start of a project, that you don't add like extra complexity? Because when you have a case where developing an application now in this subject, when you start, you say, oh, we can then deploy translation, we can add a lot of flashy things,
Exactly.
At the end, we choose the same thing.
Totally. Do you guys know Ken Beck? Do you know who Ken Beck is? Have you ever heard about extreme programming?
It's true.
Sí, you heard about that.
Yeah.
Well, one of the things that the Ken Beck was, the extreme programming philosophy, it's a book like this, like this. And you can, it's my recommendation. Every software engineer should read extreme programming. It's not about programming. It's not like it's going to give you ideas of how to write the best code. The key of extreme programming is in the title. It's embracing change. It means that basically you need to be aware that changes will always happen. So one of the things, one of this sentence that I like from Ken Beck that says, perfect is a verb, it's not a noun. You are always designing, you are always perfecting. To answer your question is how to avoid complexity or excessive complexity. Start small. Start small, don't design big cathedrals at the beginning, try to think 5 steps forward and say, oh, but I need to prepare for this and well, sure, this will come. Build something for today. Build something for what you know already. Build something that is changeable. Change will happen. So make something that works today, is a minimal but viable product, solves a problem, and be prepared for the change. How can you be prepared for change? Writing tests, using refactoring techniques, being aware of the evolution of technology, and being prepared to change one for the other. All these things is my strong recommendation to avoid excessive complexity is try to avoid big design cathedrals. Design for today. Start small, build MVPs, and embrace change with software engineering techniques such as test-driven development or refactoring. That's the best way of building software.
So, do you recommend taking any of the certifications that these cloud providers offers?
Yes, because that's how the market works. And you know, it's a way to learn. First thing, I mean, you learn. Not as much as you learn hands-on, for sure. Because at the end of the day, a certification is like the driving license. You study for the exam and you pass the exam, and that doesn't make you an architect or an AWS expert. You just say on a paper that you are. It's like any other certification. Our certification is good. Well, it doesn't prove you are an expert, but it helps you in the market, in the hiring market. So I don't want to sound naive, but that's how the market works. I mean, companies are looking at certification. So are they valid? No, they are a piece of shit. It doesn't tell you anything. But let's be realistic. Companies look at certification.
No, I have several questions, but before doing the questions, because later maybe you don't give attention. One thing that Pablo said is that we are going to offer, and the offer is going to be published very soon, for a fellow, a beca, a practice, working with Pablo and with me on researching. So it's to do some research on this, especially what he was saying about how to analyze the code and the decisions, and how the decisions of making these things in the cloud, how do they affect the code. For example, the cost of the costs of the business, and also even the sustainability. So we want to do some research on that. So I will announce that very soon. I mean, we did already an announcement. We have one person who is a mathematician in the team. We are going to be a team. We want to put in the team one people who wants to do the calculations, the mathematical calculations. But I think it's important also to have in the same team someone like you who is more from software architecture and who wants to do some research on that. Okay, so we will announce that. And the idea is that will be down probably starting next May until October, and that's what is. And it's going to be compatible with the status. I know that if you are in third year course, you can do it at the same time as you are studying. Okay? In December and then later in October. So the idea is to do some research collaborating with Pablo and with me. Okay. And before finishing, I have some other questions. Do you have about servers level agreements with AWS? How do they work? What happens when something breaks? What do you do?
Yeah, actually, that is one of the main characteristics of the services. You know, when they offer you something as a service, there are some service level agreements, and they say basically it's like if I consume a Lambda function or something, they say it's going to be available 99.9999% of the time, right? All this kind of things. So basically how it works is, well, yeah, they try to meet it, they try to meet the agreement. They always meet the agreement. Otherwise, I don't know the contract by heart, but you could even request refunds. So if they don't meet the agreement, you can say, just give me for this month's bill, I'm not going to pay it, and you are in your right to not pay your bill because they didn't meet the agreement. That's in the terms, modified or something like that. But, I mean, I can say that there is no problem with that. AWS, well, not only AWS, every cloud provider today they enable them with that problem. That's no problem. But something that we do internally is even if those availabilities numbers are very high, we always design for kind of redundancy. Even if AWS says, don't worry, this never will go down. We don't care. We know that if a region goes down in AWS, you are screwed. So in our case, we have some data redundancy in our application. Just if a region goes down, that it happened in November last year, AWS region completely went down for 5 hours, 6 hours. Well, 6 hours is a business, that's a lot. What we do is we have some redundant design. And this is something very interesting because people say, oh, that's why multi-cloud is important. Because if AWS goes down, I have the same application, hot application, already running on Google, so I can switch. It's like, oh, no, that's not multi-cloud. Basically what you need is, if you want some type of redundancy, just go and switch to another region within AWS. Right? You don't need another cloud and having both applications running at the same time on the cloud. Well, there are nuances and details with all that, but the whole idea of multi-cloud, many people are using multi-cloud for this kind of disaster recovery or redundancy, and that's something you can achieve with multi-region.
Because I can imagine that this is much cheaper if you do it changing regions between AWS than if you change.
Exactly. Data replication, for example, data replication between 2 regions in AWS is like nothing, but if you want to move your data out from the AWS and replicate out of Google, be prepared to pay a lot. Yes, exactly.
Another question was about the databases, because I know the databases they are nice, and you could have the external platform, the database to the cloud, but sometimes the companies they have their own databases, or they don't want to put that in so maybe that's how do you handle the databases in this? Well, how do you separate everything from the database, or you the platform is including the database? Because it's not the same if you have, for example, microservices, you have the small databases for your microservice, but if you have I can imagine a big company with a big database, that's a different story.
Yeah, there's a nice story that I didn't happen to me, but I read it. So the AWS folks, they visited a bank. And so it was AWS consultants and AWS sales people. They visit the bank and they say, guys, you need to move your Oracle databases to the cloud because you are paying a lot of licenses to Oracle, and and you can offer the same performance and everything on AWS. And the people in the bank started to laugh, saying, you don't understand banking, dude. It's like, forget about it. It's impossible to migrate data from a bank from on-prem, on Oracle, on their data center to AWS. There are certain cases where it's almost impossible. It's totally impossible because of the performance, because of the latency, because of the data criticality, because of the regulation, but you can't just move to the database. So moving a database from a bank or an insurance company, from what they have today to the cloud, you can move pieces, or even, not pieces, but even if they release a new product, for example, or a new type of mortgage, or a new insurance product, you can easily introduce the idea is for this product you can use the relational database in the cloud. At that point, there's another point of decision: is do I use a managed service or do I use Oracle on a virtual machine? Which is the other point. Well, it depends, and sometimes it's just Oracle in a virtual machine, but then you need to understand the Oracle pricing, or it's maybe MySQL in a virtual machine. That happens a lot. Or no, maybe I use DynamoDB or RDMS managed service. So for new products, in our case, we've seen how companies are embracing, the cloud and managed services for building new products. But for the old products, it's very, very, very complicated. Very complicated.
So that's what you need an architect for.
That's basically what you need an architect. Yeah.
Because I think in this picture here, the technical platform is nice, but for example, I can imagine that the technical platform is nice, and you have microservices, but if you want to work with very large database is not so simple.
No. There are cases where you still need the more traditional mindset to say, no. I mean, not everything can run on the cloud. For example, Roblox. You know Roblox, right, guys? They made a business case to move everything to the cloud. Everything to the cloud. And Roblox, I mean, don't tell this story to Roblox. They're gonna laugh at you. It's like, oh my God, my sweet summer child. What are you saying? We can't run on the cloud. I mean, not even serverless. We just can't run virtual machines on the cloud. Why? Their business requires latency. For them, latency is critical. It's like number one requirement, latency. They run their own servers. They run their own data centers. They don't have anything in the cloud. Well, they've got small things on the cloud. But the business critical part for them, while the games run and the core platform runs on their data centers. They run their own data centers. Why? As I said, because they can't afford 1 millisecond latency that the cloud is giving them. Because if you move to the cloud and you move to things like this and virtual machines, there's always kind of latency because you need to go to Virginia or you need to go to London where the cloud data center is, right? And Roblox can't afford that. Say, no, that's too much. And AWS says, but it's going to cost me 2 milliseconds of latency. I can't afford 2 milliseconds. My gamers will move to another platform. So that's why they run Roblox on their data centers. Because for them, they run their servers and virtual machines because they can't control the latency. They can't even afford, if a region goes down, they can't afford it. They just need to make sure that everything runs as they want. And for them, latency, availability, and all these kind of things are critical to the business. Because if you're using Roblox and you move to, and it's lagging or lagging, I'm sure you will move to a platform. They can't afford that. That's why they don't use the cloud. There are multiple cases where, I'm not even talking about serverless, I'm talking about cloud, virtual machines in the cloud. And Roblox is one example.
More questions?
So maybe in the future you either work for AWS or Roblox, I don't know. And if you work for Roblox or AWS, forget about all this because you will be managing them.
Okay, no more questions?